Can everybody hear me? I don't hear a thing.
We can hear
Yes,
you,
sir.
sir.
So we can hear you.
And I appreciate and enjoy the silence, but I was concerned maybe we had some kind of technical problem.
No, Suki.
So again, these kind of tie in with the rep grade. I know there's going to be an email sent out to your families or parents this weekend on the camera, because I know some people don't have cameras. So they're going to give you a link where you can get one for like under $10 that you can then just plug into a USB port on laptop or desktop or whatever it is. All right. So I think you're supposed to get that today. Mr. Valise is just joining us right now. So if this was the Monday after Easter and Mr. Valise can hear me, I would not allow him into class since he's not here at the start of class. He'd have to go watch the video to get the lesson. Any questions or comments on that? I can clarify. Everybody good? Okay, let me go over some housekeeping chores. Let's see. Let me just talk about a couple of things. You had a 5-1 quiz that was due yesterday in Dropbox, and I've marked who submitted it, and only about half of you have done it unless you put it in an email. But if the email's dated today, or I don't have you signed off as of an hour or two ago, it's late and you'll lose some points. So if you want a 5-1 grade, when I leave here probably at 4 or 5 o'clock today, printing out old quizzes for this class and everything else, you'll only miss a few points for not having it in by yesterday. So make sure I'd prefer it being Dropbox because I can easily see who I'm missing. But if you've got some kind of Dropbox issue or problem, send it to me in the email. But if it's not in by today, and anything else in by today that you may be missing, then I'm not going to take stuff after Easter that was due before Easter. You're just going to get a 0. We're going to move on. Because I've got a stack of about 2 inches high of problem sets, quizzes from all 5 classes that I'm going to dive through over the next couple days and after Easter, early next week. And when we come back, I'm not going to take stuff from pre-Easter. Any questions on that? I see Mr. Bunch, you've got a question. If you evidently you didn't watch the video of the class you missed on Tuesday, so you may want to watch that video. And then you may want to go to Blackboard and look for the assignment for Tuesday the 7th. There should be a quiz there and a quiz attached. You take it and you put it back in the Dropbox. Any other questions on that? Any questions on any of the housekeeping, bookkeeping IOUs before we start? Everybody still hear me all right? Everybody's unusually quiet for some reason.
Yes, we can hear you, sir.
Hey,
Suki,
Jaden.
we can hear you. Suki.
Hey, Eddie.
All right, so game plan for today. You're supposed to have put in Dropbox, and it looks like only about half of you did that too, was the 5-2 problem set number 1 that we did on Tuesday, this guy. And I put, there was 15 problems total. I think we either did 7 or 8 on the board, so you only had about 7 or no more than 8 to do. All right, so I'm gonna do a little kind of quick reminder, refresher on that. I've got the answers on the board, so you want to check your answers versus my answers. And then today we're going to get into a little more complex methodology of dividing polynomials. And I'm going to show you 2 methods for dividing polynomials. One is long division, which some of you may recall from your late middle school days. All right. And let me let Mr. Curzon in. He's customarily late, but at least he showed up today. Mr. Curzon.
I think he was eating a burrito, sir.
Make sure you're on time on class after the Easter break, because if you're late after Easter break, we don't let you in. You just have to take the class, watched it on the YouTube channel.
So my computer was working.
Well, good. You got 12 days to figure out the bugs.
Oh.
Thank you.
So I'm going to show you 2 ways of dividing polynomials. One's a long division way, and one's called synthetic division.
Suki.
They both accomplish the same thing. They both accomplish the same thing, and I'm not going to make you learn them both. but you want to become proficient in at least one of the two ways. So,
Coach, sir.
yes, sir.
All right, for the homework that was due today, what was that called?
5-2 problem set 1, and it should have been from like the 7th.
Got it.
Okay.
Thank you, sir.
So any other questions before we get rolling in the lesson?
Sir, I'm going to drop it in your Dropbox right now.
All right.
Suki, let's get rolling.
Let me give you a brief refresher. I'm going to use, let's see here, come in a little closer. St. Gertrude's people are not very good camera people. We'll make,
Dang!
okay, so I'm going to do number 3 just to kind of refresh our memory. This method of dividing polynomials. I'm going to use number 3, and what was the other one I used? 30x, what was that? Yeah, number 10. So you can, again, just to refresh our memories, and then I'm going to show you the answers so you can check your answers versus mine, because it's real hard. One of the things that's lost in this new method of teaching is it's hard for me to give you, feedback of how you're doing with the way we're doing things. So you're going to have to kind of do your own self
You got to write this down.
of how you're solving them. Well, hopefully, I'm hoping you've got the problem set there in front of you, and you can.
Okay.
I'll put them up.
It's just
slide
like
over. Yeah, just to make sure that hopefully we're getting the same answers. All right. So this was number 3. It was, well, you can read it. Hopefully everybody can see that. I'll come in a little closer. 60a squared b cubed minus 48b4 and so on, all divided by 12ab squared. And I said to maybe make things simpler and more manageable. You may want to look at this as kind of 3 problems within one, all right? With each one of those numerator components divided by the same denominator. And that's what you did, all right? And just to kind of refresh our memory of how to do this is okay. We go 60 divided by 12 is 5, so I've taken care of that. I've got an a squared in the numerator, a in the denominator, so 2 minus 1 is a. And I got b cubed over b squared, so 3 minus 2 is 1. So it's 5ab minus minus 48, negative 48 divided by 12 now is a negative 4. I've got an a in the denominator, but not an a in the numerator, so the a just stays down in the denominator position. I can't move it up top because that would make it a negative exponent, and we don't want any negative exponents. I've got b to the 4th and b over b squared, so 4 minus 2 is 2. So it's 5ab minus 4b squared over 8. And now we're going to divide negative 84 by that same item. Negative 84 goes divided by 12 is what, 7? Yeah, is a negative 7. I've got a to the 5th over a, which becomes a to the 4th. And I've got b squared over b squared, and anything over itself equals 1, right? So this is what your final answer should have been for number 3. Questions? All right. Now, similarly, that was number 3. Here's number 10, right? So each one of these, again, this, and this is each going to be divided by negative 6x squared y. So negative 30 divided by negative 6 is a positive 5. I've got x cubed as the numerator and x squared in the denominator, so that leaves x. And y over y cancels out, right? Because anything over itself always equals 1. Now I've got 12 divided by negative 6 now becomes a negative 2. I've got x squared over x squared, so that equates to 1. Anything over itself equals 1. And I've got y squared over y, so 2 minus 1 is y to the 1st. And the last part of this is negative 18 divided by negative 6 is now a positive 3. X squared over x squared cancels to 1, and y over y equalizes to 1. So there's your final answer. Does that make sense, and is that what you did? Any confusion?
Sir,
Yes, sir.
can I sign into the Zoom off my mom's computer? Because right now I'm on my phone. It'll be easier if I do it off my mom's
Anything for
computer.
you, Mr. Daughtry. Go ahead.
Yeah, just what's the name going to be?
Mama Sloan.
Mama Salone.
Okay.
I'm
So,
coming.
grab your problems. You should already have your problem set. Let me zoom in. Here's the answers for the problems that I just didn't do, or that we didn't do on Tuesday. There's the answers. Take a look at them. Let me see if I can get them all in. Let me go back a little bit. Hopefully it's still big enough for you to read. Actually, we'll do the top half, and then I'll move down to the lower half. So take a look and see if there's anything I need to clear up. Take a look. Is everybody good? Any questions? I'll move it down here in just a second. Are we getting these answers or anything? This is the time for me to clear up any confusion or misconceptions.
Sir, what is it? Wrong,
If you want to see a different way of doing this, you can always go to Khan Academy and just type in dividing polynomials, or that other website I've sent you a couple times, that Patrick JMT. I kind of like the way he does it, because you're kind of looking over his right shoulder, and he's just got, plain paper there and a big old Sharpie, and you're just kind of looking at him work through it over his shoulder. So just go to that site and type in dividing polynomials if you want a different explanation on the same process. I'm going to slide down a little bit since I didn't hear any questions. There's the bottom half of the problems. Again, these are the ones that we were supposed to do for homework that we didn't do in class. And they're not the two that I just demoed over there. We all good before we move on? Can I move on down? Are we good? Everybody up to speed?
We're good, Suki.
All right. Everybody's up to speed before I slide down the board a little bit? I just want to confirm, are we doing these correctly? Any questions or confusion?
Yes.
Okay, I'm going to move down. All right, so let's talk about this. You don't have to, because I'm going to put them on the board. Just come up a little bit. I'm going to put them on the. I've got them on the board. Okay, so now we're going to divide polynomials. So in Blackboard, if you happen to have a printer that you can access fairly quickly, it should be under today's assignment. It's section 5.2, problem set number 2. And if you notice, I've changed how we're doing things. I'm putting all these things in PDF format because of the issue where, I don't know if it's Blackboard or something else is messing up exponents. And they're either leaving them off, dropping them, or changing the problem somewhere in the transmission from me to you. Either on my end going to you, or your end receiving, or something.
Sir, is this on there now?
I'm doing everything as PDFs, so that should alleviate that problem. So it's on there now. I put it on there a couple hours ago. And I'm only saying that if you've got a printer where you can quickly access it, but it's not necessary right now to do that. But this problem set is on there. It's only got it's problems 4 through 9. So there's only 5 problems, and we're going to do 3 or 4 of them right now. So you can hand copy them, all right, to get the practice. And then on Blackboard is problem set number 3 that you're going to do between now and Tuesday after Easter. It probably has about 10 problems on it. Okay, so now I'm going to teach you 2 methods of dividing these, and I'm going to do both methods for each problem so that you can see the 2 different methodologies, and you can pick whichever one you want. Long division, they used to teach really, it was taught till you're blue in the face back in my day. Now with calculators, it's kind of gone over lightly. In most people I've found just really aren't that great at long division, but it does work well and does work. And it seems like from teaching this in previous years, most of the guys kind of trend towards the synthetic division. But you choose. I'm not going to hold you accountable to make you say, okay, you got to use long on this one and synthetic on that one. Pick the one you like and get good at it. Okay? So without any questions, here we go. Let me know if you can't see this. I'm going to come in a little bit and I'll move this. The problem is 2x squared minus 5x minus 3. It's a polynomial divided by a polynomial, which is different from those ones that we did on problem set number 1. All right? Now I got a plus minus.
Do we got to copy this down?
You can copy or you can watch me. Okay?
But it's not homework or nothing?
This is actually number 4 on the problem. Say again?
Is this not homework or nothing?
No, I'm not going to grade it. I'm going to, because I want to demonstrate the two different methods. But you may want to copy it as a reference. There's also an example on your problem set. Okay, so we're going to divide this polynomial by this polynomial. All right. So this is long division. Remember, hopefully you remember, back 6-7 years ago, where you had to divide 8 by, let's say, 340. Hope this won't come out even. 8 by 346. So 8 goes into 32 4 times, right? 8 goes into 34 4 times. 4 times 8 is 32. We put that underneath it. We subtract that from this and get what's left. So if I subtract 32 from 34, I get 2. And then we bring the 6 down, right? And then I divide 8 into 26, goes 3 times. 3 times 8 is 24. And then I subtract the 24 from the 26, and I get 2. So 346 divided by 8 is 43 with the remainder. Sometimes I made you write R. In this case, we're going to do plus 2 over 8, or 1/4. So that would be the answer. If you put it in your calculator, you're going to get 43.25, right? But that's the mechanics of long division. And that's what we're going to do with this polynomial. Questions? Did you guys do long division? Does it look familiar?
A long time ago.
Yeah.
I was like 9.
Back in my day, we didn't have calculators, so you had to do it all, scratch it out on paper just like that. Okay, so here's the setup, all right? Now, let's see. All right, so we're going to divide 2x squared minus 5x minus 3 by x minus 3. All right, so what we want to do is kind of like we did over here. We want to start eliminating, get things to zero out or eliminate out, all right? So this 2x squared, if I have 2x squared divided by x, what does that equal? Just like what we did in the previous section.
X.
It equals 2x, right? Because x squared over x equals x, the 2 just stays as is. All right, so I want to eliminate going right down the line, left to right, 2x. So we're always going to put the exact same variable with the exact same exponent over each other. So I'm going to put 2x right here. Because it's the same variable with the same exponent or same power. Okay, so now just like we did over here, 2x times x is 2x squared, which is what we were trying to achieve anyway, right? 2x times negative 3 is a negative 6x, right? And we're going to subtract that bottom row from that top row. All right, so 2x squared minus 2x squared, that zeroes out. There's nothing left there, right? And I got negative 5x minus a negative 6x, so that's x, right? Because it's really negative 5x plus 6x. Are we good? All right, and then we bring the negative 3 down. All right, so how many x's? X divided by x is what? How many x's are in x? That's a better way to put it. 1, right? So it's a positive 1. So now I'm going to go 1 times x is x. 1 times negative 3 is negative 3. I subtract. That zeroes out. That zeroes out. There's my final answer. Okay? Does that make sense?
Sort of.
Okay, now that's long division. I'm going to show you synthetic division. Now, the problem set 3 has the recipe or the process for synthetic division. It's not on problem set 2, but I'm using problem set 2 to teach you both. So it's spelled out on problem set 3 in a box. It's on the top half of the page. So here's the exact same problem, right? 2x squared. Let me see if I can come in a little closer, a little further down. 2x squared minus 5x minus 3. Okay, here's the process. We ready? I'm going to take the coefficient of those 3 components of that polynomial. So I want 2, I want -5, and I want -3. That's all I did. I just took the coefficient with the sign. Okay? I'll worry about the x's in a moment. All right. Our divisor is x minus 3. So what you do is you make a little box here. And we're going to take that -3. No matter what that value is up here of x minus 3 or x plus 3, we're going to take that coefficient, or that value, that constant actually, 3, and we're going to reverse the sign. In this case, it was -3, so we're going to use +3. If that had happened to have been +3, we're going to use -3. Good so far? All right, leave a nice space, and we're going to draw a line. Still good? Okay. So here we go. The 2 comes down, as is, 2. All right. Now we're going to go 3 times 2 equals 6. All right. Instead of subtracting like we did in a long division, we're adding. Okay, we're adding. Why are we adding? Because we changed the sign of that second half of the divisor. And I didn't create this process, and I didn't do this arbitrarily. This is the way you're supposed to do it. But we're adding because this was a -3, and now it's a +3. And usually we're better at adding than we are at subtracting. So -5 plus 6 is 1, right? So now we go 3 times 1, and that goes up here. 3 times 1 is 3. -3 plus 3 is 0. Okay, so we just divided this by the second half of that previous polynomial of x minus 3. Now we got to address the x. How do we do that? Very simply. Whatever our greatest variable is with exponent is we start 1 less than that. So our greatest variable is x squared, so 1 exponent less than that is x. So it's 2x plus 1. That would have been, this right here would have been our remainder. So there's our answer, the 2x plus 1, right here, which is the same as the answer you had up here. So that's synthetic. This is long division. And I'm going to do at least 2 more of each, just to so that you kind of get into a rhythm and routine of solving this. Any questions or comments before we do another one?
No, sir.
All right, hearing none, we'll slide down. Let's see. This whole thing up here. Yeah. All right, it's all there. All right. So this is, and these numbers are right because this problem set is just problems 4 through 9. All right, so we got the problem m squared minus 3m minus 7 divided by m plus 2. Long division. I'm going to go a little faster since we've already done one. All right. So if I put m squared over m, I get m, right? So there's one m, or m squared is the same as m over n, right? If I do this, that equals m, right? Okay, so I know to eliminate this first off, I'm going to eliminate going left to right. That's m, and as I said, we're always going to match the exact same variable with the exact same exponent on top of each other. So here we go. M times m is m squared. M times 2 is plus 2m. Draw the line. In this case, we're subtracting. M squared minus m squared is 0. Negative 3m minus 2m is a negative 5m. All right? So negative 5m over m is a negative 5, right? So negative 5 goes here, and this matches constant, constant. Negative 5 times m, oops, I forgot one thing. Bring the negative 7 down. So negative 5 times m is negative 5m, which is what we want, because we want to eliminate this next kind of column. And negative 5 times 2 is a negative 10. I want to subtract again, not add. Negative 5m minus a negative 5m is plus 5m, so that's 0, which is what I want. I got a negative 7 plus 10 is a positive 3. All right, so my answer is m minus 5 with the remainder of plus 3 over the divisor, which is m plus 2. And there's my answer. Too high, can we see that? Yeah. So that's long division. Again, I'm going to show you synthetic. I would pick one that you kind of like, yeah, I like this one better. I'm better at this one, and go with it. Don't do both. But I'm giving you both just so that you got options. It's always always good to have options. Any question before I do synthetic? So I'm going to go a little faster. All right, so the coefficient of that m squared is 1. The coefficient of that one is a negative 3, and that's a constant. All right. And our divisor is, where would I go? M plus 2, so it's a negative 2. I reversed the sign of that second half of the divisor, right? Because we divided by m plus 2 in the previous problem. We draw a line, leave it a space to write some numbers. The 1 comes all the way down as written. The negative 2 times 1 becomes negative 2. Now we're adding, right? So negative 3 plus a negative 2 is a negative 5. The negative 2 times a negative 5 now is a positive 10. We add negative 7 to positive 10 for a positive 3. So what we did here was we just took care of the plus 2 of that divisor of m plus 2. And to address the m is we start with one less exponential power than what the dividend is being divided by. So this is just going to be 1m, and we're not going to write 1m, we're just going to write m, minus 5 plus, and so there's no variable here because that's the last, if we go down sequential exponential powers, there's nothing less than m to the first. And this is my remainder of plus 3 over the divisor of m plus 2. And we're done. And as you can see, it's the exact same answer we got with the long. Okay, questions? All right. Everybody sleeping, or is this just too easy?
Just tired, sir.
You guys are quiet. Okay, let's see here. Let me make sure you can see what we're doing. All right, now we're going to throw a little curveball in here. All right, so we've got p cubed minus 6 divided by p minus 1. Okay, this is really the only kind of watch out for, make sure of, be careful of kind of deal here. All right, I don't have a p squared. I don't have a p to the first. So I've got to create, for lack of a better term, a placeholder to do both of these processes, either long and synthetic. All right, so we're going to divide p minus 1. We're going to divide, our divisor is p minus 1. And we're going to divide p cubed. And I'm just going to create a placeholder. I wrote the powers here just to show what they are. I'm using 0. All right, so 0 to the second, because there is no p squared. There's 0 to the first, because there is no p. And then there's the negative 6. Let me get some of this stuff out of there. Questions on that before we go? All right, so now if I had, sure you can see this, if I had p cubed over p, what's that equal? Which is what I want to know. I need to know to get started. That equals p squared, right? Make sense? That's kind of like we did in that previous problems, or last section's problem set. So p squared, so this is my squared position, so I'm going to write p squared right there. So p squared times p is p cubed. P squared times negative 1 is negative p squared, right? we draw the line. Remember, in long division, we're subtracting, so p cubed minus p cubed zeros out. I got 0 squared minus a negative p squared, so that's a positive p squared. And let's see here, the 0 comes down, all right? So now I want to, what do I multiply p squared at for it to 0 out? It's divided by b. By p is another p, right? P to the first power. It's a positive. So p times p is p squared. P times -1 is a negative p. Right? Kind of see a pattern happening here. P squared minus p squared zeros out, and 0 minus a negative p is a positive p. All right? -6 comes down. All right? How many p's? P over p is equal to 1. So that's a positive 1. So 1 times p is p. 1 times -1 is -1. I subtract once again. And I got 0, and I got -6 minus a -1 is the same as +1. So that's a -5. So my final answer, hopefully you can see, is p squared plus p plus 1 minus 5 over the divisor of p minus 1. That's our remainder that didn't equally divide into that. Looks like Mr. Bunch likes this. See if you've been here on Tuesday, Mr. Bunch, this would probably go a lot smoother and easier. So you may want to go back and watch Tuesday's video. Okay, so now we're going to do synthetic, all right? I'm going to erase a little bit of this just to get some of the clutter out. All right, so we got p cubed minus 6. Make sure you can see this. I'm going to come down a little bit. I'm going to slide over a little bit. All right, so p cubed, let's see here, is 1. That's my coefficient, right? I don't have a p squared. I don't have a p to the first power, but I got a -6. Our divisor is -1, which we reverse the sign of, so we're going to actually use a +1. Am I on screen? Yep. All right. We draw a line with a space. The 1 comes down as 1. 1 times 1 is 1, right? So that's a 1 there. Here we're adding, right? We add because we changed the sign of the second half of that divisor. So 0 plus 1 is 1. This kind of gets repetitive. 1 times 1 again is 1. 0 plus 1 is 1. Let's see, and then we got 1 times 1 is 1. And -6 plus 1 is a -5. All right. So we started with p cubed. And to address the p that we didn't address in this part of the process, this becomes 1p squared, right? Where we're going to get rid of, we don't need the, if the coefficient is 1, we don't write. So that's p squared. This becomes plus p, right? Because it's plus 1, right? This is just plus 1. And then it's -5 over, or -5, over p plus 1. So it's p squared plus p plus 1 with a remainder of -5 over p plus 1. That -5 over p plus 1, that's the remainder that didn't evenly divide into p cubed minus 6. Clear as mud. All right. What can I clarify or re-explain or address that was lacking? Does it make sense?
Yes.
So
So
we
keep
have any
well,
homework tonight?
There was 2 at the same time, but I'm not sure who it was.
Eddie can go first. Is there any homework tonight?
Okay, so let's see, 4, 5, let me tell you straight. Okay.
3
so
more
we did
problems.
Okay, here listen up. 4, 5, we did 4, 5, 6. There's 3 more problems on problem set number 2. 7, 8, and 9. I didn't do. All right. 7, 8, and 9. So you got those 3 problems, right? Do those for practice. Again, I would select one of these 2 methods and just do it, become real good in one as opposed to okay in 2. Select one of those two methods. And then between now and Tuesday after Easter, about what, 12 days from now, download problem set number 3. I think it was about, I can tell you how many are on there. Let's see.
So homework over the break?
Yeah, here's problem set 3. There's 2 problems in the front, and here's the recipe. Here's the recipe here on synthetic division, which is just what I just explained to you, but it's here you got a nice clean printed,
Question.
easy to follow. And then there's about 8 problems on the back. So
Question.
that would be due
Get it, Jaden.
in the Dropbox prior to Tuesday morning that I see you again. Okay, so I can look at it and see where we are.
Question.
My friend had the question.
So, sir, basically, there's homework over the break.
No,
Fix it.
yeah, I never said that.
Oh,
You
no.
got Monday and Tuesday after Easter break.
Oh, after Easter
Oh,
break.
after
Or you
break.
can do it today,
Son, don't.
school day, and you'd be done. Or you can do it on the Monday or Tuesday when we come back, as long as I've got it in the Dropbox by that Tuesday morning so I can see how you're doing.
Oh, that's so mean.
No.
Yeah.
The learning never stops at Beast.
Good times.
Suzuki.
Be early.
All right, what else can I clear up on either housekeeping, IOUs, or what we did, the lesson?
We're all good, sir.
First, I have a question, sir.
Oh,
Dinner on you tonight, sir, at your house?
Yeah.
Yeah, cookout.
Sir, cook out of Mr. Gaffney's house.
Yeah.
I
sir.
we have to practice social distancing.
Nah.
Nah.
Oh,
Not for food.
Suki, no.
Sir, it's okay. White people can't get it.
What was I going to say? Okay, the word of caution on either synthetic or long is make sure you look at the line.
Long.
None of the exponential numbers were deleted. So make sure it's got a t cubed, t squared, t to the first constant. If not, you got to put a placeholder in. If you don't put the placeholder in, your answer is going to be way off. So make sure you do that. For you latecomers, we won't mention any names, Mr. Daughtry and Curzonat and others.
You don't have to do that to my
Sure, the new rules go into effect when we come back. You've got to have a camera that's on, and they're going to send you how to get a inexpensive camera if you need one. But you
Nah.
plug in a USB port. You got to be on at the beginning of class. No hats, hoodies, vaping, food.
Sir, you said no. So you said no vaping.
Class. If you're late, I had someone vaping in another class.
no, vaping.
Infiltrator, sir.
That's the best.
He's pulling Jeeves.
Can we eat
So,
No burritos?
otherwise, you may not be admitted to class, and you're going to have to watch it on YouTube,
Why don't you like them saying Boston burrito?
which is less efficient than being in class, because this way I can't see like Mr.
Because they
Jack
got me.
smiling face, to brighten my day.
Sir, let's be real. We don't really want to see Mr. Jackson's smiley face, sir. I'm kidding, sir. Mr. Jackson is my friend.
But what's wrong with Boston burrito? Like, why is that bad?
Yeah, what is a Boston burrito?
Boston burrito.
Why don't you ask the knuckleheads that's only
Don't
the
worry
only
about
term
it.
in their vocabulary?
What is it?
What is
Something
it?
tasty. It's what it is.
Big old Memphis mud slap.
All right.
Those are the
Okay.
best.
San Fran salad.
Mr. Bunch, did I get all your questions answered and everything?
Sweetest snowball.
Back, we missed you on Tuesday. Have a very nice Easter. Stay
See you later.
healthy and enjoy the time with your family. All right.
Oh, do we have to?
Eddie.
We'll see you
Eddie,
about a
hop
week
on the
and a
game.
half.
Eddie, hop on the game.
Hold on,
Eddie,
do
hop
I
on
have
the
to,
game. Eddie, hop on the game.
get the participation for the week? Do I have to join the next thing?
Yes, sir. Unless you already got in with on office hours earlier this week.
Jaden, did you get your office hours?
What you mean office hours?
But after this,
He wouldn't know about that because he always signs in late, and so he misses the announcement. So he.
Mr. Gaffney, to be honest with you, you're walling, sir. We have to do
All
it.
right, I'll be there.
Wait,
See you
sir.
later. You're late every day, Mr. Daughtry.
So, sir, I don't have my participation points.
No, you gotta. Oh, I don't know about you. You late. I don't know.
Sir, do I have my participation points? I'm here.
You gotta be in class on time, and you gotta also check in at least one time a week into office hours.
So now I have my office. So now I have my participation points.
But if I don't join the next day, I only get a 90. Right.
You gotta cool off.
As long as you were not late for class and you weren't vaping or wearing a hoodie.
So, sir, so then right now I have 100. I mean, I have a 90.
Spring break.
Mr. Daughtry,
So, sir, I have a 90.
Mr. Daughtry,
No,
you signed in at 1:25 on Tuesday. Today. I can't give you full, you only come into like half.
We good to leave.
Sir,
right?
it's only 5 minutes late. Who cares?
Okay, so 5 times 2 minus the
You were
10.
25 minutes late on Tuesday.
To leave, right?
But, sir, I wasn't 25 minutes late today.
On Tuesday, today's Thursday, I said Tuesday.
Sir, today's Thursday, not Tuesday. Why are we talking about Tuesday?
Explaining your rep grade.
Oh,
All
my
right.
God.
Any
Sir, do
other-
I have my participation points or what?
You've got some, but you don't have 100. You're late today. You were extremely late on Tuesday. You have,
Sir, everybody's late once in a while. I was hungry.
and they lose points too. I'm not singling you out.
Sir, this is outrageous. Sir.
Last call for questions.
Sir, I have a question. Can I get my points back?
Next, in 2 weeks, you can earn new points.
So that's so long.
Sir, that is crazy.
And I'm going to miss you, Mr. Curzonette. Mr. Curzonette, you were late also. And you weren't even here on Tuesday, Mr. Curzonette.
So I had to take care of some stuff.
All right, so you can get
All
some
right,
of those points. You can get some of those points
Wait, did
back
I get points?
Hey, sir,
watching the
I'm
class
outie.
by watching the class on YouTube and then writing a summary or a list of bullet points of what we covered and send them
Sir,
to.
I'm Audi 5,000, sir. I'm going to see you later.
Okay. All right, everybody have a nice Easter, and we'll see you in a week and a half.
Mr. Gaff.
Yes, sir.
I have a personal question about my grade. Like, I have a 0 in for a quiz.
Yeah, I've got a stack of like 2 inches of papers that need to be graded and put in, and it's probably going to take me till Monday to work my way through it.
Okay, because I think that's the only thing I'm missing.
Yeah,
Right. Oh, and
I've
that's
got
pretty-
several things I know I've printed out for you that I've got sitting over there to grade that I've
Yeah.
just with having to do this new lesson plan every day. I have to do my grading like on weekends.
Okay.
Okay, I know I've got it. Just give me
Okay.
Monday. I'm hoping by Monday I'm got everything back up to speed.
All right. Sounds good. All right.
All right.
Thanks. Have a
Okay,
good one.
we'll see you.